For our next topic, okay, we would like to define the concept of degree. So the concept of a degree is an equation that we are going to use for both directed and undirected graph. So what is this equation? Now we will give a symbol. Degree between brackets V is the number of edges that are incident on V. So we will count the edges that are connected to a certain vertex and which represents the incident edges. Now we'll give them a name, or we'll give it a name, and we will call it degree. So what is the degree equation? This is the degree equation. It says if you take the summation of the degrees of all vertices and add them together, it will be equal to twice number of edges. And that makes logical. Why it makes logical? Let's go for an example. Now imagine now, for example, this graph. Now this edge, for example, if I want to count the number of incident edges for all vertices, now this edge will contribute 1 for A1 and will contribute for A4 as well. So if I tell you what is the degree for A1, then you will say 1, 2, 3. And if I tell you what is the degree of A4, then you will say 1 and 2. And see, this edge is counted twice. So this is why if you take the degree for each vertex and you add them together, it will be equal to twice number of edges. So this is for undirected graph. And for directed graph, since we have arrows on the edges, then we have to differentiate between arrows that are going out from the vertex and arrows that are going into the vertex. For example, if this is our vertex and we have a label inside it, and so we have two cases. We have arrows that are going out and we have arrows that are going into the vertex. Now we need to differentiate between the two. The ones that are going inside, we will call them n degree and we will label them a plus. And the ones that are going out from the vertex are out degree, we will label them minus. So we have n degree and we have out degree. Now the equation for the undirected graph is obvious. You take the summation of all degrees for all vertices and it should be equal to twice number of edges. And for the directed graphs, we need to take the summation of all n degree vertices and the summation of all out degree vertices and verify they are equal to the number of edges. Here is an example on undirected graph. So we have 1, 2, we have 3 vertices. Now we need to count the number of incident edges, which is the degree for each vertex. For V1, there are no edges adjacent to V1, so V1 is, there are no vertices adjacent to V1, so V1 is isolated, so the degree is 0. Now for V2, there are 2 incident edges, so the degree of V2 is equal to 2. Now for V3. For V3, if you want to count the edges, this is 1, this is 2. Now for the loop, if you just hide it like that, maybe if you look at it like that without this portion, then notice here you have 2 vertices. So maybe I should draw it here. So if you just hide this part, then you can look at it as this is one edge and this is another edge. So one edge is for going out and one edge for coming. So this is why for loops, you have to count the number of this edge twice. So we say the degree for V3 is 4. So this is 1, this is 2, this is a 3, and this is 4. So whenever you have a loop, just simply multiply it by 2 to get the answer. Now add them. 2 plus 4 is equal to 6. And see the number of edges, we have 3. So the loop is one edge. So this is one edge, this is another edge, this is the third edge. So 6 is equal to twice number of edges, which is equal to 3. Now for directed graph. Now this is a picture of, just to remind you that for n degree is a plus and for out degree is minus. And we would like to find the degree for each of these for n and for out. So for the first vertex, which is A, we need to find degree of A plus, we need to find degree of B plus, and we need to find degree of C plus, and we would like to find degree for D plus. Remember that the plus, it means n arrows. So we need to count how many n arrows for each vertex. Let's go for A. For A, how many arrows do we have going into A? So we have 1 and we have 2. So the answer is 2. Now for B, how many n arrows do we have? We have 1, we have 2 only. So these are out, so we have only 2. So this answer will be 2. Now for C, how many n arrows do we have? We have only 1. So the answer here is 1. And finally for D, how many n arrows? We have 1, 2, and 3. So here we have 3. If you take the summation is equal to 8. So 2 plus 2 plus 1 plus 3 is 8. Now let us take the plus degree for the same vertices. So degree A minus, degree B minus, degree C minus, and degree D minus. And for minus, it is number of out arrows. So let's go for A. How many out arrow do we have? We have 1, this is out, and also we have 1 which is out, so here we have 2. Now for B, how many out arrows? We have 1 and we have 2, so also here we have 2. And now for C, how many out arrow? We have 1, we have 2, and we have 3, so we have 3. And finally for D, we have only 1 out arrow, so it's equal to 1. So the summation, if this is a plus, then the summation of minus is also equal to E. And notice now that the number of edges, if you want to count them, this is 1, 2, 3, 4, 5, 6, 7, and 8. So the number of edges is 8. And see the out arrow, number of n arrow degree is 8, and number of out arrow is equal to 8. Next is to discuss what's called the degree set or a degree sequence. So let me write the definition for the degree set or the degree sequence. So here I'm going to write degree sequence or set. So what is the definition? It is the set of degrees of a graph listed in ascending order. And usually that this graph is undirected graph. If I want to draw a graph as an example here, suppose I have this graph, and here I have a loop, and here we have an edge, and we have parallel edges. Now if I want to list the degrees, now the degree for this one is 4, the degree for this one is 4, the degree for this one is 3, and the degree of this one also 3. So let's make it smaller. So if we don't have this edge, just remove it. And so this will be degree 3. And this will be degree 2. So the degree sequence, if I want to list the degree sequence, the smallest is 2. So we have 2, 3, 3, and 4. And regardless of the labels of the vertices, and see from the degree sequence, you can tell that here you have 4 vertices. And if you have the graph, then you can find the degree sequence easily. But if you have the degree sequence, then finding the graph is not unique. You can draw you can draw different graphs for the same set of degree sequence. Let's go for some examples to show you by that. Before you draw it, make sure that the graph exists. So how to prove that the graph exists? By using the degree equation. So we need to find the summation of the degrees, 1 plus 2 plus 3 plus 4. So 3 plus 7, this is equal to 10. And since the number is even, so this is a twice number of edges. So we expect that the number of edges will be 5. So this gives me a hint that the number of edges is going to be 5. Next, since the graph exists, since the summation is even, then the graph exists. Okay. And here I should draw, now this the one is the number of edges. So let's give it a try and try to draw it by trial and error. As a first trial, I expect that I have 4 vertices and I will put them in this order. And I will just randomly draw an edge between these two and between these two and between these two. So here we have degree 1, degree 3, and degree 2. Now if I want to make 2, this is degree 1, sorry. So make it degree 2. So this is degree 2. So now we have degree 3, degree 1, degree 2, and degree 2. If I want to make this one now degree 4, this is what's remaining. I can draw a loop around it by drawing a loop around it, and it becomes the degree 4. So this is one drawing of the graph, or we can draw it differently by using parallel edges. Maybe I should try by trying this. So here I'm going to draw parallel edges. So here we have a 3, here we have 1, and we have 2. And now how to make this vertex, what's remaining is degree 4. Maybe I should draw parallel edges between these two. And now this will become of degree 4. And this will become of degree 2. And now we have found all the degrees of the degree sequence. For our next example, which is number 2, first we need to verify that the sum of the degree is even. So the sum of the degree of all vertices when I goes from 1 up to n, this will be equal 1 plus 1 plus 1 plus 4, and this is 7. And notice it is not even, and since not even, so the graph does not exist. Now for the third example, the set of degrees 1, 1, 1, 2, and 3, so the number of vertices is 5. Before we proceed, like example 1 and 2, we need to find the summation. So 1 plus 1 plus 1 plus 2 plus 3. So this is 5 plus 3 is 8, so it's equal to 2 times 4. And since it is even, and this is the number of edges, which is 4, then the graph exists. Now by trial and error, maybe I can put the vertices in random order, and they are 5. So if I draw, for example, try like this, put 1 in here, 1 in here, and 1 in here, 1 of degree. So if we put an edge like this, so this is degree 1, this is degree 1, this is degree 1, and this is degree 2. So we have found the set of degrees. So this is 1, this is 2, this is a 3, and this is 1, and this is 1, and this is the set of degrees. For example number 4, draw a simple graph. For example 1 and 2 and 3, it says any graph. So you can draw loops, you can draw parallel edges, but when it says simple graph, now you are restricted, no loops and no parallel edges. Like before, we take the summation 2 plus 3 times 3 plus 5. So 9 plus 2 is 11. 11 plus 5 is 16. So 2 times 8. So it is even. So it should, the graph exist, and this should be the number of edges. Now if you try to draw it, remember you have 5 vertices. So let us draw it. This is 1, this is 2, this is 3, this is 4, and this is 5. Now if I want to draw edges between vertices, since loops and parallel edges are not allowed, so the maximum number of edges that I can connect for a vertex to other vertices will be equal to 4. Loops are not allowed, parallel edges are not allowed, so the maximum will be equal to 4. But what about this vertex? It has degree 5. So how we can draw a vertex of degree 5 and the maximum number of vertices for a degree in a simple graph is 4. So the graph does not exist, and we need to write this. Then the graph does not exist because there is a vertex of degree 5 and the maximum number of incident edges of any simple graph with 5 vertices is 4, and this tells me that the graph does not exist. What about if the graph is not simple? Okay, so and this will be for number 5. So the graph, any graph with the same set of degrees, we found the summation, it was even. So we can draw it now. Since in the previous example, we found the summation. See, we found the summation and it was even. And since the graph is any graph, then the graph exists, and the number of edges will be equal to 8. So let us draw it, since loops and parallel edges are allowed. For trying, you put one here, and you make adjacent vertices between these, and you put the 5th one. So here we have, this is degree 3, this is degree 3, and this is degree 2. And now if I want to make the other ones 3 and 5, so I'll put a loop here, so this will be 5, and here I will put also a loop, so this will be 3. So now we have number of vertices 3 equal to 3, one is 2 and one is 5, and we found the set of the degrees of the graph.